My name is Anthony. I'm from GD2B. I made this video for the CA2 mathematics to explain task 1, which is about a parametric equation, which is the first one is a straight line motion and the second one is a circle one. Okay, let's get right into it. So in the first one, an object moves in a straight line and at a constant speed from the point to 22 point minus 3 when t equals 3 to the point 12, 17, 20 seconds later. So let's do this first. Okay, so what we know is we have the start and finish point, which the start is 22 point and minus 3, and then the finish is 12, 17. And then the time start is 3, and then it says 20 seconds later with this finish 23. Okay, now the first thing to do is to find the equation, which is formula that I use is y minus y1 over y2 minus y1, and then the same with the x minus x1 divided by x2 minus x1. So just plug it in the numbers and then you get out the equation is y equals minus 2x plus 41. So the next, after you get the equation of the line, you can get the speed. With some physics, speed is distance over time. So the distance we're looking at is the quite simple one, is take the x of the both. So x2 minus x1 over the t2 minus t1, that will give you the speed. See, careful with this, you have the minus, because you can see we start at the very far 22 and then go back to 12, so that's why minus is just the direction of the speed. You can include this, you cannot, but it's really easy to me to include the minus and then just put it on in the calculation later on. So now you want to search for the xt and yt. So what is xt? Xt is a formula that says this is the speed that we just already figured out, and t minus 3 is when the t is not start at 0. So we have 3 minus 3. If it's start at 4, then t minus 4. If it's start minus 3, then minus 2, then you have to plus that, and so on. And then the x when we start. So this is the speed, this is the time we start, and this is the x we start. Opening up the brackets, and then the calculation is we get the minus 0.5t plus 23.5. So what is yt now? Yt is the equation of y while using the xt as the x. So this bit should be x, it should be minus 2x plus 41, but like you change the x into the xt, we just search. So minus 2 equals so minus 1 over 2t plus 23.5 plus 41, which is, if you calculate it, it's going to be t minus 6. So now you get your ct, which is basically how your graphic should run. So the xt should be the one we already calculated, should be minus 1 over 2t plus 23.5, and the yt is t minus 6. So to see how the graphics is, you just put it on the table. I have the t constantly over from 0 to 23, which is, well, it's easier to see because we finished here. We start at 3, which is, you can check now the x is 22 and minus 3, which is the point we start, and the finish is 12, 17. Point before this, not really necessary, but I just really want to know what is the equation line is. So you just make a scatter plot between the xt and yt, and then there you get it. The graphic is a straight line like this. Okay, so that's about the first one. It's really straightforward because it's only a straight line, which is a constant speed as well. So it's just a really good point to remember how to find the xt, which is the speed times minus what times you start, and then the x start. Right after that, you just plug it in. You see the yt, we got the x just replaced by the xt, and then after that you just fill the blank in. That's it. That's about it for the first one. Now the second one is a bit tricky. We don't have really a step. We have to figure out the possibilities because it's a circular movement. So an object is initially at 3.3, so it starts at 3.3 and takes 180 seconds to complete a circular motion. This is important, of radius 4 about a center point of minus 1.3. Its movement is anti-clockwise. Okay, so what we know is the center point is minus 1.3. The radius is 4. Start at 3.3, 180 to finish in anti-clockwise. So the thing about a circular movement, the x and y, the xt and yt, is gonna be cosine, sine, or the other way around. So, so at this point, the possibility is under either cos, the x is cos, y is sin, or the other way around like this. Now, we have to translate all of this we know into what is this into the equation. So what we know is the center point is minus 1 and 3. Basically what it says is if we have the center point 0.0, it just be a normal cosine sine. It doesn't have to be plus or minus something, but because it's minus 1, so the x bit is going to be minus 1 and the y bit is going to be plus 3. Of course, it's outside the cos, so it will be later on. So for example, you plug it in t0 here, so cos would be, I believe it's 1 or something. I don't know. I don't have the calculator with me. So if it's okay, take sin as t equals 0. If you plus 3, then it's going to move over 3, and then if this 0 is going to be minus 1. So it's going to be start something like that. So what controls the center point is the minus and plus after the sin of cos. That's really important to remember. And now the radius. Radius is what times the cos. So 4 times the cos or 4 times the sin, that is the radius. Because if you remember the wave movement will be the length will be 8, so that will be the radius. So now it starts at 3.3, which is actually not really matters. So 3.3 just determine where the cos and sine we're talking about, which is we cannot really see without the graphics, without really counting it, so we cannot really see which one of this which one of the sec 1 and 2 is start 3.3, so we just hold it later on. And then 180 to finish and anti-clockwise, so 180, which means it takes 2 times faster to finish. Usually it takes 360 to finish, but now it takes 180, which just means it's 2t. It's simple as that. So let's get 2t, 2t, 2t. Now we have 2 possibilities between the x is cos and y is sin, or x is sin, y is cos, which is where start at 3.3 comes to matter. Now I already made the t from 0 to 360 and then count, makes the possibilities 1 and possibly 2, and then we can see right on when t is 0, when we basically start, this is 3.3, which is what exactly we want, is x 4 cos 2t minus 1 and y is equals 4 sin 2t plus 3. And then this is the correct graph, and this is set at minus 7, which is later on we will see. I hope so. It basically the same circle, is just doesn't touch the way it wants. So you can see if I make a scatter plot of this, you get the same exact graph. It just doesn't say where it will start. See, this is 2 of this is almost the same, which is actually the same. They have the same center. It just doesn't know where to start. But like with you table it like this, you can clearly see that possibility 1 start at 3.3 and the possibility 2 start at minus 1.7. So delete that. Okay. So circular movement is really tricky. So you have to translate what is controlling what is the center point, controlling radius, what it is, and then what does start at mean. So we can see how do you control the radius. So if you want to control the radius, you have to have the what times cost. So something time cost. So if you want the radius is 5, make sure 5 costs something, or and 5 cents something, or the other way around. If you want to start something, it doesn't have to be cost first or cent first. You get what I mean. So the radius is something times the number times the cent or cost, and then the next is the center point. How do you control the center point? Is cost plus something or minus something. If you want the radius is minus 1.3, so you minus the x and minus 1 dx and then plus 3 dy. That's how you get the center point. If you want to have like minus 1 and minus 2, you can minus the x and then minus 2 dy. That's how you get the center point. The next one is the speed. The speed is 180 to finish, 90 to finish, 360, even more. It's just how you multiply with the t. So 2t would be 2 times faster, and half t, which will be take more longer to finish, probably 720 or something, and then it's 3t, then it's gonna be take 90 to finish. And the starting point of the motion is just cos and sin and cos. Sin and cos usually are start at the very top here, so it should be minus 1 and 7 should be around here, and then if it's cos, the x is cos and then the y is sin, should be starting around there. So that is how you manipulate your starting point. So just swap around the cos and sine. You be grand. And then the direction would be probably the minus thing. If you go to minus, it would be minus 3. The minus 3 and minus 3 will be good clockwise, and then if you put it on the minus, it will be anti-clockwise and what so on. So it's just direction. You used to usually just minus and plus sign. So that is it. So like it's really important to remember what is the center point, radius, the start means, in order to figure out this. And the other way around, if you've given out an x equation and y equation, what does this mean? What is 4 mean or cos mean? And 2t mean? What is a minus cos mean? So on. And then I just want to explain the other motion. So I have the task 2 to help me around this. So it's just basically the graphics that we have. So this is a straight line motion and so on. So I want to explain how you create a straight line motion. So straight line motion is really simple. So you should have something constant speed, something with constant, the x is constant and y is constant. You can be anything. You just don't have any quadratic, just have one simple straight line equation. So t plus 5, 5t, t over 2 plus 6 or something like that will generate any straight line. It doesn't care. Or even it can be just y equals 4, just the y is just statically in the 4 and the x will be different. It's fine as long as it's not quadratic or even more than that. Just have a straight line motion. Now, how do you create a wave type motion? So a wave type motion, at least one of those should be a constant one, like this, and sine, a combination of sine and something that moving on. So for example, like this, I have sine in x. So I'm going to move the wave one x, and then my t is constantly moving up. The y is constantly moving up 0.01. So it's going to be waving up into the top. You can switch it around, which is going to be wave from left to right or right to left, considering the direction. So one of the x or y is going to be sin or cos, and the other one should be something that constantly moving. You cannot have constantly static, because if you have something like this, you have one of them is sin, the other one is constantly two or constantly static. You're gonna have the bouncing, so it's gonna be just moving around like this from left to right, left to right, left to right in one place, which is what we call a vertical bounce type motion. Well, this is not exactly horizontal. So if you want to make a vertical bounce, you replace this for something static. You can replace this to something and then have the y as a sin, so it would be reverse of this side. So instead of you having like this, you can have something like that. Just reverse, basically just reverse x and y, and you will have the vertical bounce movement. So for making a bounce type of movement, whether vertical or horizontal, one of them has to be static. It's constantly the same. It's either 1, 2, 3 or something like that, and the other one is going to be sine or cos. And how do you create a circular movement? I already explained. So you have gonna have the x as a cos, y as a sin, or the other way around. The x is a sin, y as a cos. So that's pretty much it. That's a parametric equation. So just to sum it up, it's actually how you manipulate the xt and the yt will create some type of movement. For example, a straight line will be, you just should have something x constantly moving, y constantly moving, or you just don't move, will be fine. It will be straight line as well. If you want a wave type movement, you have put in one of those is sine or cos, and the other one should be constantly moving. It cannot be static, the same one or the same two. But if you do have one of those is constantly 1 or 2, it's gonna be a bounce, vertical bounce and horizontal bounce. And then if you have sine and cos, or cos and sine on the x of y, x and y, you're gonna have a circular movement. And the circular movement is gonna be tricky because there's so many things that you can manipulate for the center point, radius, start at, the speed, and the direction. So that's pretty much it about the parametric equation. I hope you enjoy. Thank you.